To today's class on statistics. It's going to be just an elementary. We're going to deal with the elementary part of statistics, and we'll proceed from there. By the time we get to the class where we are able to interact. Okay, so statistics for grade 10. You're welcome to class. Now, the first thing that we should have to know is that our aim will be to look into frequency and frequency tables. So we'll know exactly what frequency is and how to draw frequency tables when we are given an array or a list, of occurrences or events or numbers, as the case may be, so that we are able to set up our frequency table as is required. And then we would also take a step further from there. We'll deal with measures of central tendency. In this video, we're going to be dealing with the mean, the arithmetic mean for now. So at the end of this class, I would expect that you have a very good idea of frequencies and how to set up your frequency table, especially using your tally method. And then, of course, how you can calculate your arithmetic mean for ungrouped data. We're going to see all of that as the class proceeds. Okay, so let's begin with frequency and frequency tables. The frequency of a particular data value is the number of times that the data value occurs. Now, it's plain English. Frequency means how often a particular thing happens or how often it occurs. So, bringing that to our discussion today, frequency would be how many times a particular value occurs in a set of values. So as an example, if you have 4 students who scored 80 in an examination, then the score of 80 is said to have a frequency of 4, okay, because there are 4 students who had that score. And usually it's represented by small letter f. Okay, so many times if you see in statistics small letter f, that's representing your frequency. Now, if you want to construct a frequency table, you need to arrange your data in ascending order of magnitude. Ascending order means from the lowest one to the highest one. Okay, so there has to be some sort of arrangement, because one of the reasons we draw frequency tables is to make our data easily readable. If you have a list, assume that you have a list of 10 or let's say 20, 30 numbers. It's more difficult to read such compared to if you have it in a table that makes it kind of easy, so that at once, at a glance, you are able to see all the information that you need concerning that particular data value. So there has to be an order, and the order that is most preferable is an ascending order. You start from the lowest value and then you graduate it up to the highest value. Okay, and then in front of each value you put the corresponding frequency. So if you had 2 as a score, let's say that there is a test that is over 5 and somebody scores 2, or let's say 3 people scored 2, then the score 2 will have a frequency of 3. So you put 3 in front of 2. The 2 would be the score, where the 3 will be the frequency, that is the number of times that appears in that class. So as an example, if the marks awarded for an assignment set for a class of 20 students were as follows. So we have this array of numbers. There are 20 of them, and these are the scores of 20 students in a particular assignment. Okay, now we want to represent this information in a frequency table. Now, all things being equal, this assignment would have been over 10 marks. So you have 6, you have 7, you have 5, you have 8, you have 4, up and up like that. All right, and remember we said that the first thing that you are to do is to arrange it in ascending order. Okay, so this is how to construct your table. The first step is to construct a table that has 3 columns. The first column will show what is being arranged. which will be the scores of the students in this case. The lowest mark is 4, so we're going to start with 4, and we will align it in ascending order, 4, 5, 6, up and up like that until we get to 10. Then the next step would be to go through the list of marks. So the first mark in the list, for example, is 6. So what we do is that we put a tally mark in front of 6. Okay, so now we have listed 4, 5, 6, 7, 8, 9, 10. And then we go through the list of marks for all the students in the class. And you can see that the first mark here is 6. So as soon as we count that 6, we'll put one tally in front of 6. We're trying to count how many 6, how many 5, how many 4 are in the list of marks. So you put a tally in front of 6 in the second column, which would be labeled tally. Okay, the third column will be labeled frequency. So the second mark on the list, for example, is 7. So you put a tally mark against 7 in the second column. And then the third mark is 5. You do the same thing, and then you continue that process on and on. I believe that this you are very familiar with, I think from your grade 8 thereabout. So I expect that there would be no challenge with this. And then the next step would be for you to count the number of tally marks for each, and then write that in the third column. Third column is your frequency, so you write the number of tally marks in that particular column. So your table looks like this. When you're done, you have all the marks 4, 5, 6, 7, 8, 9, 10. And then going through the list of marks, you realize that there are 2 students who got 4 out of 10. So you have 2 in your frequency. And then the same thing for 5. There are 5 marks was scored by 2 students. 6 marks was scored by 4 students, on and on like that. So this is what your frequency table looks like. So it means that if I look at this table at one glance, I know how many people scored 8. You see, it's easier because I just look right in front of 8 and I see that 8 appeared 4 times. That makes it easier than for me to have to scan through the list of marks. And sometimes there is a mistake while I'm scanning through and I miss one of the marks, or I mistakenly had one of the marks. But when you have such a table like this, it becomes quite easy for you to be able to pick out the information that you need from your table. Now, there's also what we call class intervals or groups, and I'm sure that you are also familiar with these. Now, it's possible for us to have a set of data values that are spread out to the extent that it's difficult to set up a frequency table for every data value, because there'll be too many rows. For example, if you had an examination and the score was over 100, and there were, let's say, 50 students in the class, the scores could spread out so much. Someone might score 10, another 20, another 50, another 70. It's just there like that. And it will be difficult for you to list out all the numbers and start putting the frequency or the tally in front of them. You have too many rows, and then what you're trying to avoid is exactly where you are landing again. It's becoming more cumbersome, because you can't look at it at a glance and pick your information. So what we do in such a case is that we group the data together using what we call the class interval. So rather than give a column to 1, a column to 2, a column to 3, when we know we're going to 100, then we just give a column to 1 to 10. So we just say, okay, let's use a class interval of 1 to 10. So everybody that's scored between 1 and 10 will be on a single row. That makes it a lot easier to, interpret and analyze the data that we have. So usually you are to have between 5 or 10 rows in your frequency table. Okay, it's not good if the number of rows are too short, and then obviously it makes analyzing the data difficult if the number of rows are too long. So you make sure that they are between 5 or 10 rows in that frequency table. And this is important because you will decide your class interval. You'll decide, am I picking from 1 to 10, or I'm picking from 1 to 5, or I'm picking from 1 to 20. And you would have to keep that in mind. You would have to keep in mind that you need at least 5 rows and nothing more than 10. when you are picking your class interval. So I'm sure you can do your divisions to be able to get the necessary class interval using that idea. So each group will start with a data value that is a multiple of that group. For example, if the size of your group is 5, then the groups should start at 5, and then you have the next one start at 10. For example, if I decide that I want my class interval to be 5, okay, now I'm talking about scores in an examination, okay? It's possible that somebody scored 0, somebody scored 1, somebody scored 6, somebody scored 7, on and on like that. So I decided that, okay, I want to group my classes in 5s. I want to make it a group of 5. So the class interval will be 5. If I start from 0, the first row will not be 0 to 5. Because if I say 0 to 5, then I have 6 values and not 5. Okay, because 0 is inclusive. Okay, so I would have 0, 1, 2, 3, 4. You realize that if you start counting from 0, by the time you get to 4, you already have 5 values. You already have 5 marks. You understand? Just like you do in your number bases, where base 2 will have 2 numbers. If you remember, base 2 we have 2 numbers, and those 2 numbers are 0 and 1. Okay, in the same vein, when you are doing your class interval, okay, you must make sure that if you are grouping in 5s, then you're starting from 0 in the first row and you are ending on 4. The second row would have to start with 5, okay, which is a multiple of 5. Remember, we are grouping in 5s. Okay, so the second row will start on 5, which is a multiple of 5. That 5 times 1 will give you 5. And then the third row will start 5 times 2, which will be on 10. So the first row will be 0 to 4, second row will be 5 to 9, third row would be 10 to 14, the other one will be 15 to 19, on and on like that, until you get to 95 to 99. Okay, and then you're able to capture all your values at once. So if you have a size of 10, if your class interval is 10, then the first row will be 0 to 9, and then the second row would have to start with 10. The third row will have to start with 20, and on like that. Okay, so of course, now when you are dealing with the frequency of this kind of grouped data, every value that falls within a particular range or a particular interval will have to be in front of that row. So for example, if my grouping is 0 to 4, then everybody that scores between 0 and 4 will appear in that group. Okay? So if somebody scored 0, I would mark a tally 1 in front of that group 0 to 4. If another person scores 4, I'll still mark another tally in the same row. Okay, because everybody that scores between 0 and 4 will be on that row. So like just grouping them together so that I don't have too much information to process at the same time. So now let's look at this example. It says that the number of calls from motorists per day for roadside service was recorded for the month of December 2003, and the results were as follows. Set up a frequency table for this data value. So we have a number of values, which is representing the number of times that motorists repaired their cars at a roadside service station. So we have 28, 122, 212. Now look at this data. The lowest of them is 28, and the highest, I believe, is 217. You can see that there's so much gap. The range is high. All right, so it's difficult for us to list from say 28 to 217. We list 28, 29, 30. That's just unreasonable. It becomes more cumbersome than this array of values that we have. So what we do is to group these together, and then we'll be able to set up our frequency table and interpret our data in an easier way. So if you want to construct a frequency table for this kind of data, this is what you do. Now, the first thing you have to do is to know the range. Range is the difference between the lowest value and the highest value. Okay, you need to know how wide you're trying to go. You need to know how wide you're trying to capture, and then knowing that will give you a picture of what your class interval should be. Okay, because don't forget that your number of rows must be between 5 and 10. So putting all that in mind, in this particular example, our highest data is 217, our lowest data is 28. Now, if you want to look at the range, in this case, that would be the highest value minus the smallest value, and then that would be 217 minus 28, which will give you 189. So now, if you have 189 and you're trying to divide it into maybe 5 groups or 5 rows or things like that, then our width or class interval should be something around 40. So if we choose 40 as our class interval, then the number of classes will be approximately 5, like you can see on the screen. So this is a reasonable, this is a reasonable class interval. So we can make our class interval to be 40, so that we would have between 5 and 6 rows, which is okay based on the instructions that we have been given. So the first thing we need to do, of course, is to construct a table. There are 3 columns. You remember, the first column would be for the data group or the class interval. Remember, this time we are dealing with grouped data. So you have to the first column will be for your class interval, and the size is 40. So you start from 0 to 39. Remember, you start from 0 to 39. Because our class interval is 40, remember I told you that each of your rows must start with a multiple of 40. So if the first row is 0, it will be 0 to 39. You won't land on 40. 40 would begin the second row because your class interval is 40. And then, of course, 80 will begin the third row because your class interval is 40. And, of course, 80 is a multiple of 40. And then the fourth row, like that, will start with 120, the other guy with 160, the other one with 200, up and up like that. Okay, until all the data is captured. Okay, so if you do that, you would realize that there will be 6 groups, which is fine. We said that the groups must be between 5 and 10. So if we have 6 groups, that's good. Now, the second step is to go through the list of data values. Remember, just like we did in the first example, you go through the list of data values. And our first value here is 28. But if you look at our table, if you look at the table, you realize that you don't have 28. You have 0 to 39. So what you do is to mark one tally in front of 0 to 39 because 28 belongs in that row. Okay, so in the second column, which is for tally, you just put that. And then for the second data, which is 122, you put a tally in front of the group 120 to 159, on and on like that, until you are able to go through all the data that we have. And then the third step is to count the number of tally marks for each group, and then write it in the third column. So now this is what it looks like. The first column, which is our class interval, the first row you have 0 to 39, and there was only one value that we were given that falls between 0 and 39, which is 28, the very first value that we had. So the frequency there is 1. For the second row, between 40 and 79, you have 5 tallies, so the frequency is 5. And then the third one, you have 12, and then, and the sum that we have here is the sum of our frequency. Okay, the sum of our frequency would be equal to the number of values that we had. If you count the number of data that we were given, you realize that we have 31. There are 6 rows. There are 3 rows of 10 values each, and then 1 extra row that has only 1. So that's 31, which is the exact same value we get by adding this frequency. Why is this important? Because if you missed one of the data you were given, you would be able to notice by the time you had your frequency. If you do your summation F or summation frequency, if you do that and it doesn't give you the exact same value as the number of data that you are given, then something must have been missed. All right, so you have to go over it again and be sure that you counted each and every data that you are given. So now, quickly, let's look at the measure of central tendency. Central tendency is a way of summarizing the entire data. Now, something like, I'm sure you are familiar with something like your class average. As a matter of fact, you are promoted with your average, your term average, or whatever it's called. your first term, your second term, your third term, added together, divided by 3, gives us a picture of your performance for the entire session. So basically, that's we're trying to find the central tendency, something that represents everything in the data. Okay, so we're looking for a single value that can represent the entire data. That's what it means when we talk about measures of central tendency, and there are 3 that we commonly use. Of course, with time you would go into higher ones. There are quite a number of them, but for now we'll be looking at these 3: your arithmetic mean, your median, and your mode. I'm very sure that none of this is strange to you. You're familiar with all of this. Now, the arithmetic mean. Now, just like the example I gave you about your section average, when your first term, second term, and third terms are added together, divided by the number of terms. Or, imagine that a student joined the school in maybe second term, so the student missed the first term examination. Now, it would be unreasonable for us to add the 2 term, second term result, and third term result, and then divide by 3, because the student didn't participate in the first term exam. So what we do is to divide by 2. Okay, that's what it means to find the mean or the average. It could be called average or it could be called mean. You add all the data, divide by the number of data. Okay, whatever you get would be somewhere in the middle of all the data that you are given. So something like an equilibrium, so to say, for the entire data. So now, if we have let's say a family whose monthly income, let's assume we have 6 families, and the monthly income for these 6 families, one family makes 1,600, the other 1,500, the other one 1,400, 1,525, 1,625, and 1,630. Now, this is what each of these families earn per month. Now, if we want to know the mean family income, we simply add all these values together and divide by 6, because there were 6 families in the selection. We counted 6 families, and so we just add together, and by the time you do that, of course, you get 1,547. So the average monthly income for those families would be 1,547. So basically that's it, and arithmetic mean is the most commonly used central tendency, and many times it's the one that is closest to to the truth, if I would say it that way. Okay, it's one that is most times closest to what represents everything put together. So it is defined as the sum of the values of all observation divided by the number of observations, and is denoted by X bar. You have this bar or prime at the top of your X. Your X is representing each of the values, and then X bar would be your mean. So generally, this is what it looks like. You add all the values together, and you divide by the number of values. Okay, so you start adding from the first. That's why we have X1. X1 is representing the first data. You add it to the second data, to the third, and then to the last data. You keep adding until you get to the last data, and then you divide by the number of data that you're given. Now, sometimes, in a bit to make it easier to remember, sometimes it is written in this manner. That is, X bar is equal to summation X over N. That E-looking thing is a representation for summation, that is addition. Okay, so summation S. If you are told summation S, it means add everything that all the data that you have, and then divide by the number of data that you have, and that will give you your arithmetic mean. Summation X is the sum of all observations, and N is the total number of observations that you have. Now, we will maybe look at an example or two, and then I'll give you an exercise or an assignment that you would work on before our next class. Before our next class anyway. So, if you have an ungrouped data, how do you calculate the arithmetic mean? The first method we're going to be looking at is called the direct method, which I think is what most of you are familiar with from your grade 9 thereabout. You're familiar with this direct method, and of course that's where we will start before we look at other methods of finding your arithmetic mean. Now, your direct method is what you already know. Add all the data, divide by the number of observations, and you get your answer. So let's look at an example. We want to calculate the arithmetic mean from this data that is here. It's said to be an economics test, and there are 5 students. Of course, I'm sure that you can close your eyes to answer this question. You had all the numbers together, it's just calculator work to a large degree. Add all the stuff together and divide by the number, and then that gives you your answer. So the average mark of students in the test is 56.2. Okay, and that's quite easy. So we move to another example. Now, if you look at this example, let me give you a moment to study this example and see if you can make sense out of everything that, every step that was taken there. A student scored 80%, 72%, 50%, 64%, and 74% marks in 5 subjects. You have to find the mean percentage of marks obtained by him. Of course, I believe that there is none of you that cannot solve this or does not understand what is done. You add all the data together, divide by the number, and then it gives you that value. Okay, so that's easy. Now, look at this question. It says the mean length of ropes in 40 coils is 14 meters. Let me read that statement again. The mean length of ropes in 40 coils. So there are 40 coils. That's the number of data. There are 40 of them. And the mean is 14. Now it says a new coil is added in which the length of the rope is 18 meters. So another coil was added and the length of the rope is 18 meters. So now what is the new mean? We had an initial mean for 40 coils, but now another coil is added, okay? And then we want to find the new mean for that set of data. Now for the original 40 coils of rope, of course, how did we get the mean? We got the mean by adding all the 40 lengths and divide by the number, which is 40. We added the value, the length of the wire or the ropes rather, in each of those 40 coils. So we added x1 and x2 and x3 up till x40, and then we divided by 40, and that gave us 14, which is the mean. Okay, so it means that if we cross multiply here, it means that the addition of all the length of the coil will be 560. That is 14 times 40, that will give us 560, and that's our first equation. The addition of the 40 coils, addition of the length of the 40 coils is 560. But then another coil was added, so rather than have 40 coils, we now have 41. And the addition of the 40 coils was 560. Now that we have added an extra coil, which is 18 meters, it means that the new length will increase. It will be 560 plus 18. I hope you got that clearly. It will be 560, which is the addition of the length of the rope for the 40 coils. Now we have added an extra coil, okay, which is where the length of the rope is 18. And then we add those together, 560 plus 18, and then divide by the new number, which is 41. And that will give us our new mean. All right, so 578 divided by 41 gives us 14.1 approximately. So whereas the initial mean was 14 meters, now we have 14.1 meters as our new mean. All right, so I'll give you these 2 exercises. You're submitting before the end of today. The mean height of the 10 girls of a class is 1.4 meters, and the mean height of 30 boys in the class is 1.45 meters. You have to find the mean height of the 40 students of the class. So I expect that you'd be able to do that. Then the second question says the mean age of 10 boys is calculated to be 16 years. And later it was detected that one boy's age was taken 12 years more than the actual. And another boy's age was taken 7 years less than the actual. So find the correct mean of the ages of the boys. So these questions are quite easy. Just need you to do a little thinking and then, of course, apply your formula. So I would expect that you submit these before the end of today. You know where to submit to. You're submitting into my email, abiola@dmo@gmail.com. So I would expect you to, make those submissions before the end of today. All right. So, like I said at the start, this is just the elementary part. I just wanted to remind you of the things that I expect that you already knew from your lower grades. Okay. And by the time we meet in our interactive class, we will be able to step a little bit further into this particular topic. All right. So, do have a wonderful day, and ensure that your assignment is submitted before the end of today. Okay. All right. Take care of yourselves. Bye bye.